Hello students, in this lecture I am going to tell you we are going to solve few problems based on whatever we have learned in last lecture. So in last lecture we have seen the structure of cesium chloride, then structure of NaCl and structure of ZnS, that is zinc blende. So in today's lecture we will solve a few problems based on that. So first problem, a compound cesium bromide has some same structure as cesium chloride. The centers of the two unlike ions are separated by 0.37, that is 0.37 nanometer. What is the density of cesium bromide? That is the first part. And the second part is what is the radius of bromine ion in this structure. And we have given molecular weight of cesium, that is 132.9 gram, and molecular weight of bromine, that is 79.9 gram, and radius of cesium plus is equal to 0.167 nanometer with coordination number 6. If we try to solve first part, first of all we should understand that in this structure we should have you can say in this structure we have relationship between the A, that is lattice parameter, and radius of cesium and radius of chlorine, that is this relation. And I think we have studied this relation in our previous lectures. So if we substitute the value of R plus R, that is the you can say distance between the centers of the two unlike ions, that is given 0.37 nanometer, and we will get the value of A, that is the lattice parameter. So the volume of this unit cell is A cube because it is cubical unit cell, and density will be mass by volume. So this is the molecular, you can say molecular weight of cesium, and this is the molecular weight of, let's say, bromine. Then if we add these molecular weights, that will be molecular weight of, you can say, bromine cesium bromide. If we divide it by the Avogadro's number, this will give you the molecular weight of one cesium chloride molecule, so in grams. So if we divide it by the volume of the unit cell, that will give us the density of this you can say unit cell. So like this way we can calculate the density of cesium bromide. The second part of the question says the what is the radius of bromine ion in this structure. So in order to calculate the radius of bromine ion, so this 0.37 nanometer is the, you can say, bond length or separation between the two ions, okay, which are in closest, which are touching each other. So we feel that we should directly subtract the you can say bond length, the radius of the you can say cesium from this total distance. That will give us radius of bromine, but it is not so, because the coordination number here, the coordination number which is mentioned, it is 6, but in this case if you measure, there are 8 corner atoms which are, you can say, very close to chlorine. Similarly, for this corner cesium atoms, there will be 8 chlorine atoms which are close to this cesium atom. So coordination number of each cesium atom is 8. So in order to get the radius of cesium atom corresponding to coordination number 8, we have to divide it by 0.97. So 0.167 divided by 0.97, that will give me this will be the radius of cesium with coordination number 8. So if I subtract the radius of you can say cesium atom with coordination number 8 from the you can say distance between the centers of the two ions, I will get the radius of, you can say, this is the radius of bromine ion. Like this way we can solve this problem. Similarly, we will solve where we have, let's say, we have to calculate the density of FeO, that is FeO which has an NaCl type of structure. Here also we have to assume that numbers of Fe and oxygen ions are equal and molecular masses are given. Also the radius of Fe2 plus ion, that is given, and oxygen is also given. First of all, in order to calculate the volume, we should have A, that is lattice parameter. So we have studied A, that is lattice parameter of NaCl or FeO, is 2 times radius of one ion plus radius of second ion. Okay, so here we have taken 2 times radius of, let's say, Fe plus radius of oxygen ion, and it is in nanometer, so we have multiplied it by 10 raised to minus 9, and this will give me lattice parameter, and Q of that lattice parameter is the volume of that unit cell. If I divide it by 6.022 into 10 raised to power 23, that will give me the, you can say, molecular mass in grams of NaCl molecule. There are 4 molecules in one unit cell, that's why here 4 is you can say multiplier, and density is usual term in usual form, mass upon volume, that is 6.1 into 10 raised to power 6 gram per meter cube. And last, similarly we will solve this problem also. A compound with CDS has the same structure as ZNS. The centers of the two unlike ions are separated by 0.25 nanometer. What is the volume of the unit cell? And second part is what is the density. Here also atomic masses are given. First of all, we should have a relation between radii of the corresponding atoms and lattice parameters. So here we have this relation for this ZNS type of structure, and if we substitute the value of R plus R, which is given as 0.25 nanometer, here we will get the value of A. So volume is equal to A cube, which is this much nanometer cube. Therefore density is directly obtained as 4 times, this is mass of, you can say, cadmium, this is the mass of you can say sulfur. If we similarly here also we have divided it by Avogadro's number in order to get the you can say molecular mass of CDS in grams divided by the volume, and this gives me 5 megagram per meter cube. So sometimes it is written as megagram per meter cube or gram per centimeter cube. So these two units are equivalent, and here we will stop. Thank you for watching.